Hi friends, welcome to lesson 24. So today will be our last theorem, theorem number 9. So let's enjoy only the theorem number 9, and the next lesson we're gonna do all theorem together. Yay! Okay, so let's check our previous homework first. Let's go! Let's recap what's theorem number 8, our previous theorem, okay, about the sum of opposite angles, these two. I still have some students, a few of you, they still think that these two angles are the same, that opposite angles are the same. No, they are not the same, okay, they are not the same. They add up to 180 degrees. So to find A, you need to use 180 to minus B. To find B, you need 180 to minus the A. Remember that theorem, okay? Right, let's look at try 11. So try 11, okay, please tick your answer here. Okay, 32, 28, and 62. Okay, try it 12, 110. This one I think no problem. Okay, for exercise 3.2, there are some questions here that I ask you to DIY, do it yourself, okay? So let's look at 4A first. 4A is 64, I think no problem. You need to find this by dividing by 2. This one we use twice, okay? We use twice. And then the 126 over here, the Y here, the opposite angles is add up to 180, not the same, okay? So this one is 116, okay? And then as for B, okay, this is 72, but X is not 72, 108, because I still see a few of you still give me a wrong one answer. Okay, for C, this one I think easy, 68 and then 112. D, also I think I explained to you already. And E, okay, you see, there are two cyclic quadrilateral here. Okay, this Y and 103, they are not opposite angles, because these 5 sides are not quadrilateral. It's not cyclic quadrilateral at all. So the first cyclic is the pink one. Okay, I redraw in pink. That's why our X is 77. And your Y here is the yellow cyclic. That's why 180 you need to minus 75 in order to find Y. Okay. And F I explained already. Please refer to my previous lesson video. 9A, okay, I think this one a lot of you get correct also. 118 and 31. But 10A, okay, these two 105, 103, okay? Please tick your answer, right? So, theorem number 9 tells us that angle between tangent, okay, we have a tangent line here. You look at this yellow line, this is a tangent. If you remember what is tangent, the line that's touched only at the circumference at one point only, okay? It's not crossing, but it's just touch, okay? So the angle between tangent and the chord, okay, there are so many chords here, right? 1, 2, 3, there are 3 chords over here. But if we are saying the angle between the tangent and the chord, we have a tangent line here between chord. So there are 2 possible chords here that touch the tangent, okay? You cannot say the angle between the tangent over here and the chord. This one and this one is not even between, okay? That you cannot even find the angle between this one and this one, okay? So there are 2 possible chords that it mentioned over here. I mean from the diagram here, the chord over here, the chord number 1 here, and the chord number 2 over here with the tangent, okay? So the angle between this tangent and the chord is equal to, okay, equal to what? Angle in the alternate segment. Okay, I tell you what is alternate segment first. Okay, let's look at the first chord. This first chord and with the angle here is x. So the angle between this tangent and this chord, okay, this chord here, is equal to the angle in the alternate segment. So alternate segment is basically this one here, okay? How do you know this is alternate segment? Okay, you see this chord, right? It divides this major segment and this minor segment, right? This is your segment, correct? So this is a segment that is touching this chord, this one end to this one end, okay? So the opposite angle will be this, okay, this angle over here, because from the chord at the end, okay, I mean chord number 1 here, okay, it touch this and it touch here, so this angle is x, which is the same as this angle over here, okay? So as I say, angle between tangent and chord is this, okay, this one is equal to the angle in the alternate segment. So angle in the alternate segment is this, x. So they are the same. That's why I write x. Okay. Where else, if you see the chord number 2 over here, this chord, so the alternate segment for this chord will be this lah. Okay, you see from this end chord and from this end chord touch here, this angle and this angle is the same. Okay? Now I want you to look at this circle over here. Okay, as you can see, this is a tangent line and this is the chord. Okay, not to confuse you, I will just give an example, only one pair of the angles that is the same. Okay, this tangent angle, okay, theorem number 9 tells you angle, okay, between this tangent line and this chord, okay, so this angle, you see this angle is what angle? 70 degree, is equal to the angle at the alternate segment, this one, like, go here, okay, this one, alternate angle, so this one we call alternate segment, okay, alternate segment of here, this angle is 70, okay, if I move, right, okay, even though my chord is like this short, right, this short chord, the alternate segment will be this 29, it will be the same as this 29, okay, and then look at this, okay, so this alternate segment can be anywhere, it can be like this also, not necessarily have to be like that, it can be like this, okay, as long as this chord, okay, this one line chord, the end over here going towards here and the end of this point going towards here, this one we call alternate segment, okay, they are equal. Okay, what if I move like this? Okay, you can see the 77 equals to 77, okay, 107, okay, I just want to show you how it actually looks like. Nah, okay, it's still the same. Okay, I think this is the hardest in Theorem 9, it's hardest to see lah. It's not that it's very hard, but maybe it's hard to see when it involves a lot of lines in a circle. When you combine all the theorems together, it could be a little bit hard for you to see, but it's okay. As I say, you are doing this one by one, right? Okay. Let's look at try 13 in page 105. Okay, so in the diagram, O is the center of the circle, Tn is the tangent, this is the tangent, BAT is 40. Okay, now this one, you look at this. AOP is 21. It's not in the diagram, so we have to add on this one. So OBP, this over here is 21. Okay. So we want to find APB. Okay, part A is asking you to find APB. So APB is this one. Okay. As we learn theorem number 9, right? Okay, can you identify where is the one that is equal to which one? Okay, which angle is equal to which one? If according to Theorem 9, angle between tangent and chord is equal to the angle in the alternate segment. Okay, can you see where is the angle between chord and tangent? Give you a few seconds to think of it. Okay, look at this. This is chord and this is your tangent line. So this 40 degree over here is the angle between tangent and chord, and then it's also equals to the angle at the alternate segment. Okay, so this chord, right, this chord over here, the point here and the point here, right, the end. So if it goes like this one we call alternate segment. So this one is angle in the alternate segment. So they are the same. So we can see that APB is equal to 40 degree lah. So this one is 40. According to theorem number 9, so that one is 40 degree. So part A, angle APB equals to 40 degree. Okay, so what is next? PAN is here. Alright. Okay, so can you see another alternate segment which is the same as the angle here? This angle is between tangent and chord also, right? So this angle over here is actually equals to the angle over, you see this is the chord. Okay, so it goes like this and goes like this. So here it is. Okay, same as this angle here. Okay, but the thing is, how are we going to find this? Okay, we have 21 here, but we need to find this one to find so that we can find the total angle here. Okay, but how do we find this angle? Okay, if you can see theorem number 3. Okay, what is theorem number 3? Okay, go back, go check. Go back to your previous pages. What is theorem 3? Angle between tangent and a radius, okay, is 90 degree. Can you see where is the 90 degree? Here is the 90 degree because this is radius, this is tangent, so this is 90 degree. So this angle here is 50. Okay, so if that angle is 50 degree, so this angle is also 50 degree lah. Because this one is radius, this one is also radius. Basically, this triangle is an isosceles triangle. So 50, this one is 21. Okay, so this angle is 21 plus 50. So meaning to say that this angle is also 21 plus 50. Okay, so angle PAN is equals to 50 plus 21 or 21 plus 50, which is 71 degree. Question number 5, shall we? Okay, question number 5 is in exercise 3.2, page 107. Okay, I want you to do these 4 questions. Okay, part A, you can do it yourself. Part B here, maybe I give you a little bit of hint. Okay, I give you I teach you how to do this question using theorem number 9. Okay, actually you can use another theorem also, but I'm gonna teach you theorem 9 from this. Okay. So how do we find, okay, you want to find x first. X is easy, you don't need theorem number 9. You can see this is a 90 degree. Okay, this is a right angle triangle basically. So to find this x is 180 minus 90 minus 23, right? Okay, you find it by your own. Now I'm going to teach you how to find y. So this y here, this is angle between tangent and chord. Okay, chord and tangent over here. So this is y. So if we do like this, this is alternate segment. Okay, so basically this is also your y. Okay, so angle between tangent and the chord is equal to the angle in the alternate segment. So to find this y, you just need to divide by 2 for the x, because this one is according to the angle at the center is twice the angle at the circumference. Okay, the twice theorem, remember? So after you found this x, you can just divide by 2 to find the y. That's it. Okay, easy? Okay, so this one you do it by your own. I give you the hint already on how to do this question. Okay, and for C, okay, C angle in a semicircle is here, 90 degree. Okay, I give you the hint until here. Oh, and another one. This one is 90 degree. Okay, angle between tangent and radius is 90 degree. Okay, then this one you can do by yourself. Okay, okay, for D, okay, I will teach you how to do D lah. Okay, so this is angle in a semicircle, 90 degree. Okay, you see this is diameter, this is 90 degree. This one, according to theorem number 9, is this theorem number 9? You see, this is tangent line, right? If this is tangent line, this is chord, then you can say that this x will be equal to the alternate segment here, which is also this x. Okay, so here we can use, to find x, we just use 180 minus 90 minus 58. Okay, or if you can see in another angle, okay, in another view, okay, this tangent and this chord, this one is also 58 because the alternate angle is here 58. So here is also 58 and here is 90. So x, straight line here, 180 minus 90 minus 58, you will still get the same answer. Alright, okay, so after you found this x, then you can find this y, because you can find this angle over here first. Okay, or you can do like this. You see, this is a big triangle. Okay, so basically after you find the x here, this is also your x, right? So 180, you minus the value of the x that you found, minus this 90, and minus another value of the x, the same x that you found, then you will get the y. So far so good. Okay, so all you do it by your own. Okay, all A, I don't need to teach you already, you know already. This one according to theorem number 9. And we have finished all our circle theorems. Oh wow, look at this theorem until 9. We have finally completed them. Yay! Right, so we prepare for your next lesson. Next lesson, we're gonna combine all together, theorem 1 to 9. Okay, so for today's lesson, that's all. It's only a little bit only, right? Lesson 24. What you're gonna do is your try 13, exercise 3.2, question number 5. And the end of our topics. Alright, well done guys. Right, see you guys again next lesson. Alright, bye-bye.